Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. Question number 9, 7-mark question. The function f is defined by f of x is equal to 2 over x plus 3x squared minus 3, where x cannot be equal to 0. Just an idea, why can't x be 0? Because we're dividing by x. And just as a little aside, because this is quite a common question, this would also be the point where we would have an asymptote, because we can't divide by this number at the bottom. This would be where x is equal to 0, would be our asymptote, this line that we approach, but never touch, right? That we never really reach. Okay, let me erase this. Okay, so here's a function and they ask us to find the derivative, f prime of x. Okay, not too bad of a question, pretty common question. A calculus question almost, not always, but straightforward derivatives, yeah, they're possible, but often we have this variable in the denominator, which we have to work with. Alright, so here is part A. F of x is equal to 2 over x plus 3x squared minus 3. And we know if we want to take the derivative, so I'll write it out here. This is given in your formula booklet. We have x to the power of n. If we want to take the derivative and find f prime, we multiply this exponent out in front, and then it's reduced by 1. But the question here, like x is always just, well, just by itself. It's not, they never give us 1 over x. What do we do in these cases? We always want x to be just presented not where it's in a numerator. So we don't want it at the bottom of a fraction. We want to write x as with essentially a whole number. It's just a plain value in some sense. We don't want it over in our denominator. So how can we change this 2 over x? So once again, I think we've done this before in some past videos as well, but 1 over x is equal to x to the negative 1. 1 over x squared is equal to x to the negative 2, and 1 over x to the n is of course equal to x to the negative n, whatever it is. So if we have, I'm just going to draw a little more space, if we have, let's say, 2 over x, we can represent this as 2 times 1 over x, and then this just becomes 2 times, and we know what this is just x to the negative 1, so this is 2x to the negative 1. So you can separate them, and I think that's not a bad idea. So 2 over x becomes 2 times x to the negative 1 plus 3x squared minus 3. And remember, this is still f of x. We haven't yet derived it, so don't yet put a prime here. Don't yet put a prime like that, because it's not quite the case. Here's f prime. Now we can derive it. So let's take this exponent, multiply it out in front. In this case, we have now negative 2x used to be negative 1. Let's take away 1 from this. So now it's negative 2 plus, again, grab this exponent, multiply out in front. 3 times 2 is 6. X used to be 2, take away 1, now it's just 1. And then any constant just goes away, so these plain numbers just go away. And that's our derivative, negative 2x to the negative 2 plus 6x. Find the equation of the normal to the curve y equals f of x at 1, 2 in the form of ax plus by plus d is equal to 0. And then it says where a, b, and d are, and this z means whole numbers. So whenever they want us to present an equation of a line where everything is on one side and we just have a 0 on the other, they want us to write a, b, and d, any of these values, no fractions, no decimals or anything like that. Bring everything to one side, set the other side equal to 0, no fractions, no decimals allowed. These are called integer values. So integer values. Okay, so let's see what we can do. Okay, so we want to find the equation of the normal to the curve. So if we have f of x I'm actually just going to graph this to kind of show you what it looks like real quick. So get a new window and then graph it. So here we are, 2 over x plus 3x to the negative 2 minus 3. So here's our function, and we want to find at this point negative 1, 2. So I'm just going to find this point when x is equal to 1, y is equal to 2. We want to find the normal to this curve. And so what that means is we want to find a line that's perpendicular. So not tangent, which is just going to be the slope at this given point. We want to find the perpendicular. So I'm going to go back to the document and actually sketch this out. And so as quickly as I can, I suppose, try to provide some more idea. So here's this sketch. We have this asymptote at 0 again, and then it goes down something like this. And here's this point at 1, 2, and we know if we wanted to, we could find the tangent to this line, right? The slope of a line at a given point. But in this case, we want to find what's called the normal, and that is to say we want to find the line that is perpendicular to the tangent. So the normal to this function, not the tangent, but this is the normal. Okay, and I suppose you can kind of see what is happening. If this is m, then the slope of this would be m perp, and that would help us find the equation of the normal to a given line. So how can we work this out? We want to find this perpendicular to this function right here. 2 parts of an equation of a line, slope and then the y-intercept. We have this set of points here, so we have a set of points on the line. We can find that y-intercept, but how can we find the slope? So we know that this derivative right here is given by negative 2x to the negative 2 plus 6x. And this is also called our slope function. So remember the gradient function, the slope function, the derivative, all of these things, they tell us the slope of a line at a given point. So that's what this f prime of x does. And if we have an x value here, if we know that x is equal to 1, we should be able to put that into our slope function and find the slope of a line at a given point. So let's go ahead and do that. So f prime of 1 equals negative 2, and let's input this value, and then we should be able to find the slope at that given point. So I'm just going to work this out on my calculator that I have beside me, and it's going to be negative 2 plus 6, of course, which is just going to be 4. Alright, so we know that the slope of this line at negative 1, 2 is equal to 4. So I'm actually going to write that in here. So this line right here, the slope of this tangent line at this point 1, 2 is equal to 4. Okay, so if we know that m is equal to 4, then m perpendicular, so 4 is the same as 4 over 1, m perpendicular is going to be equal to 1 over 4 multiplied by a negative. Okay, so now we've got some part of our equation of a line, y equals mx plus b. We know that this is negative 1 over 4x plus, and the question is, well, what is b? Okay, so we have a point already on the line. We have x and y values, so we actually have a point that's on this normal line. So we should be able to actually just substitute this value of 1 and 2 into the equation. So y is equal to 2 when x is equal to 1, and then we can find the value of b that way. Y is equal to 2, x is equal to 1. And we can, you can end solve for that if you want. It would be 2 plus 1/4, or it would be 9 over 4. if you do end solve this, and you do get a decimal, I think it's going to be easier if you write it out as a fraction, just because in the very, very final step, we want to write it out as this form right here, without any kind of decimals or fractions. And it's easier to convert fractions to whole numbers than decimals, I think. Okay, so our equation of a line in the end is y is equal to negative 1/4 x plus 9 over 4. And they want us in the end to write it out in this form. This ax plus by plus c is equal to 0. by plus d, thought it was. Alright, plus d is equal to 0, where this a, b, and d can have no fractions, no decimals, just whole numbers. Positive, negative whole numbers. Okay. So, first off, let's bring everything to one side. Let's bring this x over and this 9 over 4 over. Essentially what we're doing when we're bringing something to one side, we're doing the opposite. So we're adding 1/4 x to both sides, and then when they meet, negative 1/4 x, positive 1/4 x, they cancel out. But you can also think about it, when you bring it to the other side, it just has to change its side. So bringing this negative 1/4 x to the other side, it becomes positive 1/4 x. This y just stays here as it is, and bringing this negative 9/4 over to the other side, it's now going to be a negative 9/4, and that equals 0. Okay, so we have these fractions here which we don't really want. This over 4 equals over 4. This is 1/4 of an x. So if you imagine something like this, here is, let's say, a whole x, but we don't have a whole x at the moment, we just have 1/4 of an x, so this is like 1/4 of an x. But we want a whole x, we don't want any fractions or anything. What can we do is we can multiply it by 4, and that'll get rid of our fraction. This will apply in any case. If it's 1 over 5, just multiply by 5. And then for this 9 over 4, since it's also over 4, we don't want 9/4, we just want whole numbers. So we multiply everything by 4, multiply everything by the fraction. And so, let's multiply by 4, multiply by 4, and then of course this 9/4, we're going to multiply by 4 as well. So that'll just give us x, plus 4 times y gives us 4y, and 4 times negative 9 over 4 just gives us negative 9. There it is. X plus 4y minus 9 equals 0. Okay, there it is. Not a bad question. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.